So, moving on. Rate of reaction. So rate of reaction is how fast. Now we're going to go into extent. So extent is where we look at equilibrium and how far a reaction goes. What do we get as our product? How much reactant we have left, etc. So don't mix these two up. Then we need to talk quickly about irreversible versus reversible. As we're going to discuss later, and you may like to think of it like this, think about your redox reactions and think about sort of your galvanic cell versus your secondary cell. Think about secondaries technically have galvanic in them. Think about your primary, actually it's probably a better way of saying it. Think about your primary, I don't know why I did that, versus your secondary. So you've got your primary cell, you've got your secondary cell. So primary, secondary. So some of the reactions are irreversible, so products can't be converted back into the products, into the reactants. This is a irreversible. So for example, you can't unbake a cake. Whereas when we have a double arrow, so as you can see here, this is a single arrow. When you have this double arrow, which is you draw like this, and you're all gonna have to get used to this for equilibria questions. Not for everything else, always just use a normal arrow, but for equilibrium questions where you're writing out a sort of chemical reaction, it's really important you use this. And it just needs to look like that. It doesn't need to look fancy, doesn't need to look nice, just needs to look like that. So in this reaction, the products can also be converted back into the reactants. So you can go forwards and you can go backwards. So